Okay, magandang araw po. So, let's solve a sample problem here regarding variable motion. So, we have here the acceleration of a rocket traveling upward is given by this equation, acceleration as a function of s. So, a is equivalent to 6 plus 0.02 s, where a is in meter per second square and s is in meters. Determine the time needed for the rocket to reach an altitude of 100 meters. Initially, the velocity is 0 and the position is also 0 when the time is equivalent to 0. Okay, so to solve this, let's consider the given function or equation. A is 6 plus 0.02 s. So when dealing with variable motion, ginagamit lang natin mismo yung ating kinematic differential equations dito. So from the kinematic differential equations, ano doon yung may relationship ng acceleration tsaka position? So we can use the third kinematic differential equation, which is A ds equivalent to v dv. So we have here a relationship for acceleration and position. So substituting the value of acceleration, that is 6 plus 0.012s, quantity ds equivalent to v dv. So integrating both sides of the equation. So we have here, when integrating, meron tayong limits. We have the lower limit and upper limit. For the lower limit, yun yung ating initial values. Sabi dito, when the time is 0, velocity is 0 and position is 0. So the initial position is 0, the initial velocity is 0. So to a final velocity and then final displacement or position. So for this function, makakakuha tayo ng equation relating velocity and position of the rocket. So integrating the integral of 6 ds, that is 6s, plus 0.02 integral of s ds, s squared over 2. So that is from 0 to s, equivalent to the integral of v dv, that is v squared over 2. So that is from 0 to v. So simplifying further, this is 6s plus 0.01 s squared. So substitute first s, substitute as s, walang magbabago, minus, substituting the s as 0, so 6 times 0 is 0, 0.02 times 0 squared over 2 is 0, so that is 0. Equivalent to, substitute the upper limit first, that is v squared over 2, minus, substitute v as the lower limit, 0, so that is 0. So simplifying, we can get here an equation relating velocity and displacement. Simplify lang natin, velocity is quantity 12s plus 0.02 s squared raised to 1/2. So we have here an equation relating velocity and the position of the rocket. So the unknown is to get the time needed for the rocket to reach an altitude of 100 meters. So paano natin ma-relate yung time kay velocity and position? So we have to use another kinematic differential equation. Ano yun? So relating those parameters, we can use V is equivalent to ds over dt. So by cross multiplication, but yung velocity, substitute na natin dito, 12s plus 0.02 s squared raised to 1/2. So by cross multiplication, you can say that dt is equivalent to, ulit lang sila, ds over 12s plus 0.02 s squared raised to 1/2. So integrating both sides of the equation, so let's include the limits. For the lower limit, sabi dun sa problem, initially displacement is 0 and the time is 0. And then what will be the time when the altitude is equivalent to 100 meters? So that will be the requirement of the problem. So dito, pwede mo nang i-apply sa calculator yan. So for this, integral of dt is t. So applying the limits, that is t minus 0 and that is equivalent to t. So ito, apply mo lang sa calculator. But, pag in-apply natin yung calculator, itong function na to, dapat solvable na. Dahil may limits tayo eh. Kaya lang, ang makukuha yung sagot dyan ay math error or cannot be solved. Bakit? Dahil dun sa value ng lower limit. Yung ating in-integrate kasi ay rational fraction. So, dapat yung denominator ay hindi maging 0. Dapat solvable kapag sinubstitute natin mga limits. Kaya pag sinubstitute natin yung lower limit natin dito as 0, magiging 0 raised to 1/2, magiging 0. So, dapat hindi maging denominator natin ay equivalent to 0. So that the calculator can solve the given integral. So, anong gagawin natin? We can use L'Hopital's rule. Ano yung L'Hopital's rule? Instead na i-substitute natin mismo yung ating limit as 0, gagawin natin siyang approaching 0. So, ano yung approaching 0 na value? Pwede siyang 0.000000001. So, that is approaching 0. Yung ating magiging value nun. So, that will be integral of 0.00000. The more na mas madaming 0 yan, the more na mas malapit yung value na yan sa 0, mas malapit din yung sagot na makukuha natin sa value nito. So, the more zeros dyan, okay lang. Mas maganda. This is 100 meters. ds over 12s plus 0.02 s squared raised to 1/2. So, yan yung ating substitute sa calculator. Yung 100, wala nang problema doon. Kapag sinubstitute natin, may value yun and that is not 0. So, substituting or applying this into your calculator, you can solve that time is equivalent to 5.62 seconds. So, after 5.62 seconds, the rocket will reach an altitude of 100 meters from its initial position. So that will be the requirement for this given problem.